When we go to solve radical equations, our goal is to get the variable by itself and equal to some number. Before we can start rearranging the equation, we will need our restrictions. So looking at our first example, we have 3x, that's 3 times x. So we need to know what will work for the x value so that that stays positive. We have our single x, which means a negative here would result in a negative number. So when we look at our restriction, x is going to have to be greater than or equal to 0. At this stage now, we can go and solve our equation. So we have the square root of 3x is equal to 6. As we go to solve this, we want to do the opposite of what's currently happening. So, and we move from furthest away from x to closest. So that 3 is under the radical sign with the x. So we need to get rid of the radical sign. Remember, this is an index of 2. The opposite of square rooting would be 2 square. So we're going to square both sides. When we do that, the square root squared will just give us the radicand. And 6 squared is 36. So we now have 3x is equal to 36, but we want x, not 3x. Remember, a number and a variable with no sign between them is the same as multiplying, and the opposite of multiplying is to divide. So we're going to divide both sides by 3. 3 divided by 3 is 1, leaving us with x on the left-hand side. 36 divided by 3 is 12. So at this stage we now have x is equal to 12. However, because of the radical sign, we do want to check to make sure that we will have answers that work and that we don't have an extraneous root. An extraneous root is a root, an answer that does not satisfy the equation or the restrictions. So as we go to check, I'm going to write the equation as it was originally, and I'm going to write, this is the t method, so I'm going to write a line underneath the equation and one straight through the equal sign. As we go to look at this, what happens is anything that's on the left-hand side stays on the left-hand side, anything on the right-hand side stays on the right-hand side, and our goal is hopefully to have the two sides equal. So this x we're going to replace with the value that we figured out x was, which was 12. So we're going to have 3 times 12 under our square root sign. 3 times 12 is 36. And the square root of 36 is 6. So we have 6 on the left-hand side. Looking at the right-hand side, we have our 6. Comparing the left and the right-hand sides, they are the same, which means this answer here is indeed our final answer. For this example, as we go to look at our restriction, we have the plus sign, which means x plus 2 has to be greater than or equal to 0. So as we go to figure out our restriction, we have x plus 2 is greater than or equal to 0, and getting x by itself, we'll subtract 2 from both sides. 2 minus 2 is 0. We have our inequality. 0 minus 2 is negative 2. So there is our restriction. As we go then to look at solving the equation, there are, for this particular one, 2 ways we can do it. The first one, we can take a look at it and solve for x. So as we go to look at this, the opposite of squaring is to square root. So then the opposite of square rooting is to square. So we could square both sides to get rid of the square root sign. On the left-hand side, that leaves us with x plus 2. On the right-hand side, we get 9. We still want x, not x plus 2, So subtracting 2 from both sides, I get x is equal to 7. Comparing this to our restriction, it looks like x equals 7 should work, but we're going to go do a check, make sure that it does indeed work. So as we go to do our check, we have the square root of x plus 2 equals negative 3 on the other side. Down and through. Putting our 7 in for the x, we have 7 plus 2 under our square root sign. 7 plus 2 is 9. And then the square root of 9 is 3. And that is a positive 3. If we look at our right hand side, we have negative 3. These two are not the same. So one of two things have happened. Either A, we have no solution, or B, we made a mistake. Going back and taking a look at our work, all of our work is actually correct. So that's not our issue. So we are looking at this is what's called an extraneous root. And there is no solution. Okay, so we have no solution for this one. So this would be one way we could go solve it if we just went through, solved it, and did it the same way we've done previous solving of equations. Our other option for this one is if we take a look at the equation, and before we ever start trying to get x by itself, we just actually stop, take a deep breath, look at the question, and if we look at the question, we notice that there's this negative sign right there. And we stop and we think, and we go, wait a minute, there's no way I can square root a number and get a negative answer, because remember this was our 2. So if that's not possible, there's going to be no value for x that will result in this being equal to negative 3. So we could, for our other option, is say no solution. However, unlike the first way we did it, where we had the check to show y, we would have to say no solution for x, and we would have to go through and say y, which would be, because there is no possible way to square root a number and get a negative answer. Okay. So this particular one, if we'd stopped and looked at it, we could have figured it out and figured out there was no solution with our check, or taking a look at the question going, wait a minute, no way we can square root a number and get a negative answer. If we look at this example, we notice that on the left-hand side, not only do we have a square root, we also have a plus 3. Before we can get rid of that radical sign, we need to move everything else to the other side. And then again, before we do that, we need to find our restriction. So, in this case, our restriction is what's going to cause under the inequality sign to be able to be calculated. We have that minus sign, so x minus 1 has to be greater than or equal to 0. Add 1 to both sides. We get x is greater than or equal to 1. So there is our restriction. So there's our first piece. After we found that restriction, we can then go and work on solving our question. Now recall, I said when we started a radical unit that the radical sign had to go to the end of what was under the radical sign and then stop. So in this case, that radical sign stops right here, which means that 1 is under the radical sign, but the 3 is not. So before we can square both sides to get rid of the radical, we need to move this 3. Opposite of adding is to subtract. So we're going to subtract 3 from both sides. When we go to do that, on the left-hand side, we're left with our radical. So x minus 1 under the radical sign. 3 minus 3 is 0. 4 minus 3 is 1. At this stage now, the only thing on the left-hand side is that radical is the square root. So now we can square both sides to get rid of it. And when we do that, we get x minus 1 is equal to 1. Adding 1 to both sides, to move the 1 to the other side, we get x is equal to 2. Comparing our answer with our restriction, it looks like it should work, but we do want to do a quick check to double check and make sure that there isn't something happening. So we have x minus 1 under the radical sign plus 3 equals 4. Again, notice we're going with the original equation, not anywhere after we've started to rearrange it. Putting our 2 in for the x, we have 2 minus 1 under the square root sign plus 3. 2 minus 1 is 1. And then we still have our plus 3 because we haven't done anything with it yet. Remember, square root is a number times itself. So the square root of 1, 1 times 1 equals 1. So that means this is 1 plus 3. 1 plus 3 is 4. So there is our left-hand side. We have it down to the number 4. On our right-hand side, we have this 4 up here. No math needed to go with them. Comparing the two, they are the same. So that would mean that this is our final answer.